Hello everyone, I'm Krish and I'm part of this enterprise for 7+ years now, working as a tech architect. I would like to welcome all of you to the fourth edition of our tech meetup. Today we all are here for a very interesting discussion about benefits and hidden secrets of Azure API Management Service and AWS Elastic Beanstalk. I'm sure all of you must be excited and are eagerly waiting to hear from our speakers. Before we start the tech meetup today, I would like to give you a quick brief about Eastern Enterprise. Eastern Enterprise is an IT service company specialized in crafting software solutions for startups, small and medium enterprises. With an agile, ready, dynamic workforce of 350 plus technology artists, creating value in all directions. Eastern Enterprise helps 100 plus clients across Europe in creating software solutions that are robust, creative, modern, user centric. Europe is in creating software solutions and, of course, secured. Working with this enterprise, change becomes the most dynamic, powerful source of progress, and the heart and soul of this enterprise is its people. So that's a quick intro about our organization in a nutshell. You can visit www.istenterprise.com to know more about it. Now, I would like to quickly introduce you to our esteemed speakers for today and run you through the agenda of this meetup. First, we have Michael Angelo Van Dam, whom we call him as a Mike. He is a professional PHP consultant and Zen framework expert working mainly for governments and larger enterprises and will be addressing on the topic Discover the Benefits and Hidden Secrets of Azure API Management Service today. Second, we have Santosh Nagendra. He is a professional DevOps consultant with more than 10 years of experience and has been helping clients maintain their AWS cloud IT infrastructure, and he will be talking about AWS Elastic Beanstalk. Before I hand over the stage to the speakers for quick housekeeping rules for all of you present here today, in case anyone faces any issues, please feel free to post in the chat and our team will reach out to you to fix the same. In case of any queries, please don't hesitate to put the same in the comment section and our speakers will try to answer the same during our Q&A round. We'll be having the Q&A session for 10 minutes after each talk. At the end of the meetup, request you all to provide your valuable feedback as it would really help us to give a better experience in our future tech meetups. You will find the feedback form link which is already shared in the chat. So now I would like to welcome you to our first speaker, Michael Angelo. Like I said, Mike. The stage is all yours, Mike. Thank you.
Okay, thank you, Krish. Hello, everyone. I'm going to talk about APIs. Just for reference, I've been working with APIs since forever. So for me, everything seems to be very clear and very understanding. But yeah, I try to be as yeah, as forthcoming as possible. So if I go too fast, please let me know. In the meantime, I will take you on a journey to talk about API management and the hidden secrets of it. Um, what are APIs? So next slide, please. APIs are, yeah, of course, when I want to express something about a definition or something, I always go to Wikipedia. They always have these quotes. So an application programming interface API is a connection between computers or between computer programs. It's a type of software interface offering a service to other pieces of software. That's a lot of text and doesn't really emphasize on, yeah, the essence of an API. So if we have a closer look at the text, next, please. I'm looking at yeah, the connection of computers, software interfaces, and if we are taking those words in a sentence, which will be on the next. An application programming interface is a software interface providing a connection between computers or computer systems. I think this explains it a whole lot better. So, if you still have a little bit of doubt what APIs are, let me explain. APIs are for machines. They are designed to provide a way for a machine to communicate with another machine. So you can use them to build something great, and uh, when machines are talking to each other, uh, they also require one specific type of human interface, and that is called a developer. The developer is the one that actually builds the API, communicates with the API, provides the logic to consume an API, and then make sure that the machine can actually operate on that API. So let's have a look at some examples of the APIs. There are plenty of APIs readily available, but uh, to give you a good sense of okay, what are business APIs and what are consumer APIs, I split them up. You have internal ordering systems, mobile application services, industrial control services, government services, social media, and so on. And then for your consumers, you have your shopping cart. You go to the retailer, you put something in a basket, and you check out, and it all goes through an API. Your weather, to know if you need an umbrella or not in the morning, that's also an API. Your government may provide open data services to know about the levels of the water in rivers and in streams nearby. Um, you might have an alerting system about traffic on your way to work, and so on and so on and so on. So, as you can see, the world of APIs is enormous. And to give you a little bit more of an understanding of how an API actually works, is well, we use a REST API, which is based on top of the HTTP protocol, the protocol that you use inside your browser. Whenever you type in something, a URL, easternenterprise.com, your browser will take you to that website. That's over HTTP, and that's a protocol that everyone is using on the internet. REST is basically using that protocol to expose services to the outside world. And as you can see here, this is for a human resource application. You get an employee, so you make just a request for a slash employee on a URL, and then you get like a whole list of employees. That's what they call a collection. And then get employee ID, which is an entity. So you only get a single employee back. Uh, if you want to make some modifications or you want to create a new employee, well, you post towards the employee statement. If you want to make some changes to an existing employee, you use a put. So the get, post, and put are what we call HTTP verbs. And those HTTP verbs will make sure that uh, your transaction will be transferred from your system towards the system that hosts the API. And as you can see on the uh, screen, you don't have to use a HR application. You also have consumer services. For instance, Flickr. Flickr.com is a website where you can post and upload all your photos, and you can share it with the world, and people can embed them in your presentations. Um, on this particular step, you get a whole bunch of things because you're a consumer and you're not allowed to access uh, the data directly. So they expose all these get endpoints. And the output in this case is XML. In the previous slide, you saw JSON. So JSON XML is the communication technique that is being used between the systems that are providing these APIs. Nowadays, more often you will see a JSON output, but XML or CSV, uh, as long as it's a formatted structure, it will work. And if we have a deeper look at these settings, well, I can now have a specific photo element listing, and I can provide it like, okay, now I can consume it directly. I hope that this brief introduction to APIs was enough for you to understand what APIs are and what kind of purposes do they fulfill. Let's dive a little bit deeper into API management, because this is more important. And API management is, well, I think we missed a slide. The purpose of API management. There you go. Uh, well, API management is all about managing who has access to your system, what can people do on your system, um, can we also change something in the communication, maybe provide auditing and billing facilities, so hook it up with external systems and so forth. Um, if we go to the next one, um, I think API management offers a lot of things, and I think it's easier for me to explain what it's not. So next, please. So API management is not the API itself. It doesn't provide any service. It just manages services. Uh, if the API is broken because a version got some bad code in it, or a system, a backend system failed, uh, API management cannot fix this. You need to have other systems in place. It doesn't prevent direct access to the API. It sits in between your consumer and the API itself. But if people have the resource to the API, then people can still directly access it. And API management, I'm sorry, it will not clean your dishes or clean your house. That's something you have to do it. But you can build an API that actually can monitor and address some robots that will do the work for you. So that's a good thing. Um, so I've been working with APIs a whole lot of years, and more importantly, I've been working with APIs within Azure Cloud. For those of you who are not familiar with Azure Cloud is Microsoft's cloud solution that is available for independent developers, but also for organizations. And a lot of companies that are already in Office 365 are already Azure consumers, even though it's just a small portion of the Azure functionality that is being provided. Next slide, please. So Azure API Management. Azure API Management is essentially a toolbox that provides all kinds of management capabilities and versioning of your APIs. You can attach monitoring to it, you can attach access control to it, and it provides you a one solution fixes all your problems kind of option. So let's have some look at some common challenges. Uh, the first common challenge is, hey, I have internal and external APIs. How can I segregate those uh, without actually using a different domain. So I want to have everyone access it apimycompany.com slash, and then my API should be provided. Well, the easiest thing would be like, okay, you put a load balancer proxy in front of it, an application gateway, and you define your routes through there. But you also have this functionality built within the API manager of Azure. So let's have a look at the example here, procurement services. So an internal API would be, I will connect with my suppliers. I need to have access to my product and services, and I also need to fulfill my orders. The external APIs I'm consuming is, hey, I need to validate this VAT identifier. I need to access the UBO register for Belgium. Um, Maybe I want to have some additional information from LinkedIn. So as you can see, we now have internal APIs for applications that we build ourselves or host ourselves, and then we have external systems. How can we solve this? Well, the easiest way would be, and this is in a schema where I present it. Uh, yes, there you go. I hope it's readable. So no matter who is connecting, either a device or a organization or an IoT system, it will connect to your domain apicompany.com through the application gateway, which I put in place because that's the most common scenario for organizations. And then it goes into your API management. And in your API management, you can say, hey, you know what? I will provide internal routing to my APIs, and I will have a batch of external APIs like my LinkedIn, my UBO register, and Vs, and my internal APIs for my reseller and all those other things. So I can manage this right there in the center in my API management. So that little cloud thingy that you see in the center, that is my API manager. And that it will be just a simple rule that I will be defining in my application. So in the next slide, if you go to the Azure portal, you will have a functionality where you can actually say, hey, you know, this route, this is my external API. This route, this is my internal API. So that is something that you don't even have to program. It's not something that you need to configure specifically. But of course, if you do this through the portal, uh, everyone who has access to the portal can make those changes. And maybe you want to look at infrastructure as code, like, for instance, ARM templates, Bicep, or even Terraform. Um, okay. Um, in the next slide, you can see the internal or the external API being configured. There you go. Um, and if I look at both, I just access them through the same URL, and it's only the route at the end that actually makes the difference where I'm getting the response from. So okay, so that was a fairly easy challenge we could solve with an API manager. Like I said, and you can also do this in the gateway, but that's not really the whole point of this presentation. I think the next challenge would be a lot more important, rate limiting, because you don't want to have your system to be overloaded with unlimited requests. For instance, a developer is consuming your API and made an infinite loop. So instead of just calling your system maybe 4 times a day, it will call you 4 times per second. And so you want to have some rate limitation in your API request. Well, I've seen a lot of developers coming up with a whole bunch of ideas to solve this, but let me tell you, it's not something you have to worry about. It's fairly easy to implement. So let's have a look at the example, public API service. The challenge is we want to prevent the abuse and system offloading. The solutions could be, hey, we have a firewall with denial of service mitigation, or we have a rate limitation for unauthenticated users and also authenticated users. Well, for API management, it's considered to be a policy. Next slide. And more importantly, it's an inbound policy. What does it mean? We look at the request that's coming in into the API, and then we define a policy to mitigate any weird things that might occur. So, next slide, please. Azure API Management Policy is a XML-based policy where we just say rate limit by key. We allow 5 calls, and we want to have people wait for 60 seconds. And then we provide the status code 200 again if the renewal period is processed. And we use the IP address just to make sure that the person who is calling is tied to that IP address. Of course, when you're dealing with proxies, you have another challenge at hand, but let's make sure that at least people using their own IP address are countered in their attempts to overflow the API. And then we also provide a variable name, remaining calls per API, so we can also provide this in our response headers to let people know how many calls they have left. So if we look at the implementation of this policy, again, it's in the Azure Portal. You have the inbound policy set on the endpoint that you want to protect. Like I said, it's just one line that you add. And once it's in place, I can make multiple calls. And then all of a sudden, next slide, please. If I have too many requests made, I get a 429, too many requests, and I will also see retry after 50 seconds. So through just that one single line that I put in place, I now have the ability to actually prevent people from abusing my API system. So no fancy coding, no expensive hardware to put in place. No, just one line and I'm safe. I think that's amazing. So what's the next challenge? SOAP to REST. So I have an existing SOAP service, and people that have been on the internet for long enough, just like me, know that SOAP was the next best thing since sliced bread, but it's a pain to implement and a pain to process. Nowadays, everything is JSON, REST APIs, and people want to use REST APIs. Well, we could provide like a proxy in between that does the translation, but why should we? SOAP comes with a manifest, a structured guideline that says, okay, these are the endpoints, these are the parameters that we require, and this is how you implement it. So the WSDL file or WSDL, as people call it, provides all the information that you actually need to create a REST API. So let's look at the requirements again. Next slide, please. So the requirement is all APIs must be a REST service providing JSON. So SOAP is XML based and SOAP is structured through the WSDL implementation. Well, if we can go to the next one, it's very easy. We have the internet, we provide a REST API through the API management, and the API management actually exposes that REST API to the SOAP service. It will provide the translation, so to speak, automatically. How does that work? Well, in the next slide, I want to set up my API, and I have this block that I can define. And one of the block is use the WSDL. So I put a big red arrow there. That block is actually required to load up my WSDL file. As we can see in the next slide, I just provide it with the WSDL link. I don't even have to have the file. I can just upload the link. Next slide, please. There you go. So I can use the URL. I can provide either SOAP pass-through, so I can be like a guardian in between, but I just want to have the SOAP service being translated into a REST service. So this is the VAT, the VAT ID validation service from the European Commission. So I can now use that service through my API management that will convert it into a REST service. And the URL you will find at the bottom, the base URL, and that will be the entry point for all the API endpoints it will create based on the WSDL file that I upload. So on the next slide, you will see how direct it will convert it into two endpoints, check VAT and the delete VAT. And then yeah, the post operations, because that's provisioned in the WSDL file, that will be provided directly by the API. So now I can actually consume this, and I can, if we can go to the next one, I can now post to my endpoint with the check VAT um, entity endpoint that I discovered in the WSDL file. I can provide it with some data that I need to provision, the parameters that are also defined in the WSDL file. And I can now get a response saying, hey, this is the country code, this is the VAT number, and this is a valid VAT number. And I get additional details from it. So now I converted a very complex SOAP system into a very easy to consume REST API. Yes, I need to follow the structure, but yeah, if I want, I can rename those ends as well. All right, so let's look at a challenge where we can actually have some more, yeah, body on, and because these were very easy challenges. System B2B and B2C access control. This is going to be very tough, I think. Yeah. So, what are the requirements? Well, next slide, please. We want to have only authenticated users or that use our partner API or using OAuth. So we don't want to change our existing APIs, and we don't want to manage the users of our partners. And let the partners deal with their own uh, user base, and I don't want to be implemented with that. Okay, so next slide, please. In the architecture, it will be customers. They can use all kinds of social media links to connect. Uh, they're using OAuth underneath. Um, Staff and partners, they will use their Office 365 accounts or their Google Workplace or whatever kind of platform that they use. And we can have that integrated into our API management. So in the center, you will see the API manager again. It will connect with Active Directory. Active Directory will have a B2C component that will allow consumers to connect with OAuth directly. And we can have our API services completely abstracted away from unauthorized access. So if we go to the settings of Google, well, you need to have a Google account, of course, if you want to provide Google authentication. You create an API ID for it. Um, you make sure that you copy those details, and at the right top, you copy those details, and then on the Azure side of things, um, you provide the details from Google OAuth, um, and then next slide, please. So the credentials that we copied there, we're going to provide here, and once everything is provisioned, I can now have uh, uh, an additional header that I need to provide, which will be on the next slide, please. Um, so I have an internal API endpoint. I want to access the employee information, and I provide it with my subscription key and my authorization token. So the token is the Google token that will be created the moment that I have called the sign up page through OAuth. So I have that token and I can now access it, and it will work out of the box without changing anything on my API side. The API manager will take care of it. So next slide, please. And it's transparent. Um, so you don't see like there's a layer in between. No, I just make an authorized request directly to that endpoint, and I will get my response back. If I'm not authorized, I will be forced to authorize first. So was that a challenge? Well, the challenge would be that you need to go to Google, and if you want to implement Facebook and all the other things, you need to have all those APIs copy paste, copy paste. So, yeah, there is a little bit of work, but I mean, copy paste is not really that hard. Um, so, I think you will solve a lot of problems uh, through this particular instance. Okay, and I think that there's an interesting challenge waiting for us. I have this wonderful API I created. Now I want to have some people pay for it. So I want to have people consuming my API, and I want them to pay for the usage of it. So will this be very difficult? Well, a little bit. Let's have a look. Requirement. The API is a premium service and users should pay for its usage. Challenge. I don't want to change the existing API, and I want to integrate with the existing payment provider, for instance, Stripe, because I don't want to be PCI compliant and all the other things that I need to be compliant with. So how do I approach this? Well, first of all, I need to have a Stripe account. Makes sense because we need to provide it. And let's have a look at the architecture. Customers, they will connect with my API management, and they want to consume an API service. So I create a billing app that will verify if that authenticated user, yeah, So think of the previous slide in between. Um, so only authenticated users can actually consume that API endpoint. And because they're authenticated, I can have now a billing app that will calculate or monitor how many times this consumer has processed my endpoint. That billing app is also the one that actually sends that statement to Stripe, and Stripe is the one that actually will send the invoice to the customer. So as long as the customer hasn't paid the invoice, the billing app will say, you don't have access. And the moment that we do have a payment coming in through Stripe, then we can delegate that request and the user can consume the API. It's very mysterious because the hardest work will be to integrate the Stripe API in your billing app. But then, if once it's been set up, I can now have a post request made to my billing app registration or subscribe endpoint, um, and I will get an ID from that response. So next slide, please. I just provide my details to the endpoint. I get a 200 OK, and I receive an ID. And that ID is coming from Stripe. So at that point, I'm now authenticated. I now have a subscription running at Stripe. I paid my invoice with Stripe, and now I can actually consume the API. From the API management point of view, if I look at the Stripe console on the next slide, I can now see, okay, hey, I have a subscription, and it's again that same ID that actually made that subscription. So I can reference the user towards the subscription that they made and connect back to whoever is there to connect to it. So I think it's time to recap. Um, when using APIs, we need to use an API management solution. I think I made that point clear. Um, combine internal, external APIs is no longer a problem. Don't reinvent the wheel. Use those API management solutions and then focus on creating value for your customers, not maintaining the middleware. Uh, that's it. That's my focus. I do have a couple of resources for you. These are books that I can really recommend. And there's also the Azure API Management Full Lifecycle and how to publish your APIs with the new developer portal. And this is from Azure Fridays. And with that, I have some related links, API management that you can look at. I'm not sure if the PDF also have those links. Otherwise, I can make sure that you will get those links later on because, yeah, they are very interesting. If you want to play yourself with some APIs, there's on the next slide, you have the data.gov from Belgium, Europe, the Flickr API that I mentioned, and of course, everything within Azure is also provided through an API. So learn, explore, and build something great. I thank you very much. Please reach out to me on Twitter, Facebook, or LinkedIn. Thank you. I now take questions.
Thank you, Mike. It was really a wonderful talk. And yeah, it was quite interesting, and I'm sure the audience loved it as well. We'll quickly move to the question and answer section, and let's try to answer some of the queries of our audience which they have. So here we have a first query. Is it possible to set up alerts while within Azure API Management solution to monitor API endpoints availability?
Yeah, API management is all about the API itself. If you want to provide monitoring, API Manager ties into Azure Insights or Azure Application Monitoring, where you can actually define the rule sets when to alert on specific events that happen on the API.
Okay, clear.
So
And
it
what?
so monitoring is not part of the API management, but it's a better service provided next to it.
All right. And there is one more question. What are the different kind of metrics Azure API Management solution provides? Can it be categorized, like for example, based on number of calls to an endpoint by a client?
Well, it defines on the metrics could be the amount of calls, the duration of the calls, or the amount of calls in a specific time frame that have been created. It could be also the amount of endpoints uh, contacted within a certain time frame. So there are different parameters that you can use. I just use just a simple counter just to make the example work.
All right. Okay, clear. Thank you, Mike. All right. So now moving ahead, I would like to welcome our second speaker, Santosh Nagendra, who will discuss about AWS Elastic Beanstalk today. The stage is all yours, Santosh.
Hi everyone, this is Santosh Nagendra. I work for Eastern Enterprise as a cloud computing engineer. So, welcome to everyone. We can get started. So, I just spoke about myself, and I work on Kubernetes and cloud computing and everything related to cloud. So, we can go to the next slide. So at the end of this session, the key takeaways that I want to want the audience to be taking away with them is especially for the developers to be able to deploy applications using Beanstalk, demonstrate how it abstracts the complexity involved in creation of infrastructure, and more importantly, initiate an interest in the audience to explore the power of Elastic Beanstalk. So that's the goal of this session. We can move to the next slide. So let's start with the basic definition. What is Elastic Beanstalk and what AWS offers? Definition says it helps in creation of infrastructure, falls into the category of platform as a uh, service from AWS. Basically, helps in two things: create abstracts the complexity involved in creation of the underneath resources, be it computing power, memory, or any software packages that are need to be installed for running your web server, for example. It helps with that. And so this whole process is automated by Elastic Beanstalk, but it does not limit the fact that it takes charge of all of this and it is managed by AWS. Doesn't mean you do not have a flexibility or control over the infrastructure that you it provisions. You can still go ahead and configure and tune it to the needs of your application and your environment. So yeah, let's move to the next slide. So today, I'll do it in a phase where two phases where I'll try to explain the concepts that are there behind Elastic Beanstalk and have a short little um, short demo demonstrating what we are trying to do, and then come back to the slides to summarize what we just covered. So let me would like developers or audience listening to think of a scenario where you want to deploy a simple web application. So, what all would you need to deploy a web application? First and foremost, you would need a server. I wouldn't say hardware because nowadays we have virtual capacity. So that's what cloud computing is all about. So you would need a server. So in other words, a machine with some computing power and memory. a runtime and or software you can call, which can understand your application binaries. And since it's a web application, it'll be a web server, so you will need to deliver the application file. So it can be a Apache Tomcat service installed on that, or an Nginx proxy. Um, After all this, you would need to register your domain with the domain register provider. Example can be GoDaddy, or it can be Google domain name server. So you will need that. So you can think of it like whenever you need to make your application or service available to the internet, uh, you need to have your application registered on a domain name system. So, like for example, Facebook.com needs to translate into some IP address so that it is discoverable on the network of computers. Um, so in the same way, you need a domain name system for your application. In this, Elastic Beanstalk does that automatically for you. AWS Route 53 is the equivalent of GoDaddy for us. So it will register our domain and assign us a public IP so that our application can be reached via the internet. So these are the things and prerequisites that are required. So let's consider a developer who does not have an expertise to do that. Uh, it sounds like a ma- major task, right? So without having to any expertise, how do I do it? So that's where Elastic Beanstalk helps you. This can be done by uploading your source code. All you have to do is have your source code tested locally, and when you have it set and running locally, you have to zip it up in a certain format and upload the code. And the rest of the process, as I've been explaining in the past couple of slides, the creation and the deployment of your application is taken care by AWS. So let's go to the next slide. So in this today's example, I'm focusing on a very simple demo where I have a PHP application, web application, which will has some static HTML pages, which when deployed will create a web app server. This is our virtual machine that will be provisioned. In front of it will be an Elastic load balancer, which will divert traffic uh, based on the demand. uh, Initially we can start off with one instance. So these days, like when there is an increased demand for our application, we can scale up, auto scale, and that's where the power of cloud and virtual resources come into play, where we can scale on demand. And this thing that you see here, I hope you can see this, is called the Route 53, which will give our application a domain name. For example, my app dot something like Elastic Beanstalk, but it can be some other domain name which is available out there on the internet. So this will be the architecture. So let's switch to a demo. I would like to share my screen. uh, I hope you guys can see my screen. Here I have a simple PHP application with some images there for that application, and then I have some HTML, basic HTML. So I will, let's say from a developer perspective, we are trying to develop an application, and now you will test it. You will launch the application. You're doing the testing. So I go to my local host. My web application is working fine. Everything is good. Now I want to deploy this to the AWS environment. Now, this is my browser. Here I have signed into the AWS console. I've logged into a Singapore region with a demo account. You will need a AWS ID and a password to sign in. You can sign up easily, can be checked. And once you are here in this page, you have to check for in this search bar for Elastic Beanstalk, and click on this. Once you click on this, you will be on this landing page. If you have already got few environments created, otherwise it will be slightly different, but you will have a create new environment like this, which will take you back to that page. Now, the application for me is a web server. So I have chosen the web server environment. Let me give my application a name. I call it Cafe. Um, Environment name, it automatically assigns one. So this is the domain I was talking about. We can give a domain that you have already have, or you can leave it blank and then AWS will auto generate it for you. And you have to choose the runtime platform. Since mine is a PHP application, I'm going to select PHP, and it will select the runtime for me. And then I have to upload the existing version. So, okay, one thing before I choose upload code, the major requisite is the code that you have has to be bundled up in a certain format. So to do that, you can see here, I have zipped it up into a cafe.zip folder. Uh, so you need to zip up all your application into a zip file. Then this is a PHP application. If it is a Java application, you will have to bundle it as a var file. So let's go ahead, have the zip file in place. I need to click on choose a file. Okay. So I hope you can see my screen. Demo. Okay, and I'm clicking the zip file and click on open. So the file is uploaded now, and I click on create environment. So in the background, it is starting to create the environment, the necessary resources. But this process takes about 15 to 20 minutes. So in the interest of time, I cannot afford make you guys wait. So I had previously created a similar environment to keep to demonstrate it without having to make you wait. So let's see here. We have got the environment created, and we have got the domain here. If I click on this, it will uh, go to the application that I deployed, and let us see the resources it created. So we have to see the instances. So it created an instance. This is my virtual machine. Uh, Here you can see it gave it a public IP address so that it is reachable. That is, the domain name will translate into this address. That is this domain name that it automatically created. And so there are other things that we can dig into, but what I would like to show is something related to the environments. So let's go here. So configuration. Okay, so you saw that it created the EC2 instances, and the software it created was it is understanding my PHP code, so it's a PHP runtime. It is also installed a proxy server, Nginx. This is, you can think of like an Apache Tomcat. Instead of that, it is using an Nginx proxy. It has provisioned virtual instances, and here I would like to explain one interesting aspect here. Capacity. So now we can also auto trigger our instances to scale up or scale down based on certain parameters. So this is a good feature to have. Let's say we can define it on a metric such as a CPU utilization. If our CPU utilization for an average of about let's change that to percentage, for 5 minutes goes above 90%, then we can instruct it to scale up our number of instances by 1. And if it reduces to less than 20%, in that case I want to scale down my instances by 1, which means that when there is an increased demand, I want to scale up, and when there is a decreased demand for my application, I want to scale down, thereby saving cost on the computing resources. So this is a good feature that Elastic Bean offers, that you can configure your auto scaling groups. Also, there are additional configuration options such as time-based scaling. So let's say you've gone live with your application, and you see a pattern like in the mornings every day from 9 to 10 you see high traffic or spike in the traffic, uh, uh, or in the evening. So you can add a time-based scaling. You can give it a name, and you can say between this time to this time I want a minimum of 4 instances and a maximum of 10 instances. So if there is a downtime, or if the application is not performing well at this point of time, it might mean loss of revenue or loss of business. So we don't want that to happen, having analyzed the uh, analytics or the performance of our application. So we can configure this. So this is one thing I wanted to show. And in terms of monitoring, we do get other options, such as we can see the logs of our environment. We can see last 100 lines or the full logs. It will give the logs of our virtual server on which our application is deployed. Also, mm, mm, for monitoring, we have various metrics based on which visualization charts are you can see. We just created an auto scaling group based on CPU utilization. Uh, Likewise, we have for number of requests received by our web server, or number of network incoming network traffic or outgoing network traffic from our environment. Also, we can set up alarms based on this to notify a person or infrastructure or a system administrator, uh, who then based on certain parameter, like for example, I can set it on number of requests received or average CPU utilization. If it is greater than 80%, I can set this alert and send a notification, so that when the person who is responsible will know that there's something wrong with the system and can act on it, maybe provision an additional resource, or troubleshoot the problem. So this is one advantage. These are the many advantages that we get by using uh, AWS Beanstalk. Um, Along with monitoring, we get to be able to configure alarms. And since it's a managed service, you can delegate the updates to your environment to AWS. Like you see that you're running your application on a particular OS, and that OS, Windows OS or Linux OS, there is a vulnerability that is reported by the security team. Then you have to patch it up. So there is regular patches that are have to be done, or if there is some software packages, we are using PHP, and if PHP certain version has some security vulnerability, you will have to update to a latest software to mitigate or eliminate that vulnerability. So these updates can be configured to be handled automatically by AWS, and we don't have to worry about those. And so I spoke about logs. We can also see a different kind of event logs, everything that happens within our environment or system. We can also see fatal logs or error logs. I don't have much data here, so I'm not able to see. So this is in just what wanted to show with the hands-on how we deployed the application, and how it automated the creation without us doing anything other than uploading the source code. Now, can we have the slide deck back? Yeah, next slides. So this is what we went through, the cycle of how we created the application code, uploaded the uh, code with the zip file, and how it created or launched the environment, and how I showed how to manage the environment with certain configuration options that we have within the AWS console. Move on to the next. Next, this is what I covered. So this all I did it in hands-on. So we can move to the next. So the features of Elastic Beanstalk, what to summarize, what all it provided the options of load balancing, monitoring your application, and it allowed us to configure an auto scaling group, and we can also delegate manage platform updates to either update your software packages or OS upgrades. We can do that, and Elastic Beanstalk will take care of it for us. Right now, the support for Elastic Beanstalk is for major programming languages like that is mentioned here, like Go, Java, .NET. For additional programming languages, please refer to the documentation that AWS has. I'm sure it has more support, but all the popular languages and framework are covered here. Next one, please. So I showed you what all resources it created and the software stack, the Nginx proxy, and it had launched the instances on an Amazon Linux operating system. Now, suppose if you have a .NET application and you want a Windows server, that Elastic Beanstalk will scan your code according to the requirements of that your application code. It will create an Windows IIS server and install maybe .NET platform or .NET framework on that. So AWS Elastic Beanstalk is intelligent enough to understand the requirements that are present in your source code. Yeah, so move to the next. Next. So managing and configuring. So I showed you how to do load balancer. We saw it in the architecture diagram, but we can also configure it to enable stickiness. If you want, if your application has needs to enable stickiness, we can do that. We can also auto scale on different metrics. So I showed it for CPU utilization. You might want to scale it on a different metric, maybe like number of requests received. If your application is receiving, say, less than 100 requests, you might not need to scale up. But let's say it is receiving more than 1,000, then it's obvious that you want to scale up, and your application might not be performant at that stage. So you can do that. And as far the instance, the OS is concerned, you're not tied to using what Linux or any flavor of Linux. You can always choose what instance you want. Apart from what it configures, you can always go ahead and change it. Like if it is provisioning a Linux, you want to go and update, choose a different like Fedora, Red Hat. That's possible. There are some AMI images that are available within the AWS catalog, and you can choose and configure your virtual server or virtual machines. Yeah, next one. um, yeah, so for the monitoring and application, showed you how to retrieve logs, how the different category of logs that are available, uh, and how to set alarms. Like you can send a mail or trigger a notification when there is something, when a metric goes beyond a certain threshold or comes below a certain threshold. You can notify your system administrator, who can then take action if a manual intervention is required, or you can again automate it based on these metrics to auto scale or downscale your application. So that was the monitoring application section. Next one, please. So this was in summary what Elastic Beanstalk did. Apart from Elastic Beanstalk, I want to explain to the audience about CloudFront and what CloudFront offers. So what is CloudFront? It's a content delivery network which helps in fast delivery of HTML content. So how to move to the next slide and maybe explain this concept, and then we can see it in action. So when I so CloudFront, now we have a website, we have our application being delivered. So now let's say my application is deployed in a geographic region from AWS, like in a Singapore region, but I have my customers, let's say in US, Europe, or some part that is further away from where the application is deployed. And uh, consider a scenario where your application is mostly delivering static content like HTML, video files, or image files, uh, and the content is not changing rapidly, right? So you would want to cache those uh, files and application content onto these somewhere that is closer to the consumer, so that it doesn't have to hit the origin server or where the main server is located every time. So what Amazon offers by through CloudFront is it has a number of edge locations in different geographical regions. So if you say US, it will have several nodes or edge locations there where it will cache all your HTML content, be it like video files or static, all kind of static files. So it will have one in Europe or different geographical regions, and when there is and it will see if there is no change in the content when a user or a client, like say client browser browsing from a Europe region requests for data from your server, it will serve from the nearest cache onto which the files would have been uh, downloaded. So it saves time, bandwidth, and the experience that the user will have is much better than when it has to hit the original server every time. And so you can think of using this when there is a lot of HTML and static content that is present in your application. One very popular use case with Amazon CloudFront, you can say, is not Amazon CloudFront, Netflix, you can say. They have their own content delivery system. They don't rely on Amazon's, of course, but the concept that they use is the same, to deliver fast and a better experience to their users. So their video streaming services relies on these edge locations, and they have built their own content delivery network to this. And so I'll share my screen one last time to show how to create a CloudFront distribution. I hope you can see my screen. So I am in the cloud. You have to, like, we search for Beanstalk, we have to search for CloudFront, and then we will come into this page, and then we click on a create distribution. We have to choose the domain. Our domain is this, which Elastic Beanstalk previously created. We paste that. We don't need these HTTP. We just have to put the full domain name, and then there are certain other configurations that we can do, like how long you want the cache to refresh, or uh, and what all, if you want it to be HTTP secure only, all that we can do. But for now, to keep things simple, I'll just go ahead with the default option and click on create distribution. This again, it says it's deploying, so it takes time. So previously I created one for this particular application, and you can see it has given a different name. Now when you give this to the users or the clients visit your application via this, you know that this is being served through the edge location. So someone from Russia or someone from some remote part of the country tries to visit this application, it won't hit your origin server in Singapore. It will go to the nearest location in South America, or if it is from North America, it will go to the nearest edge locations that is present geographically close to the user, and that will be faster because it will be cached, all the static contents. Yeah, so that's what I wanted to speak about. Can we come back to the slide deck? Yeah, next one. So I think I explained the things that I put it in points here. I wanted to show it through the AWS console and a pictorial description. I have done that. So next one. Yeah, so I think we are at the end of the presentation. I would be glad to take if there's any questions from the audience regarding the topics. Thank you. I'll hand it back to Krish.
Thank you, Santosh. It was really an interesting talk. It was quite informative as well. And without wasting much time, let's move towards answering the audience queries. So we have one query from Amir Salam. He's asking, like, how can we integrate this with continuous CI/CD pipeline systems?
We have many options. If you want to use it with AWS only, they have something called cloud formation templates. Also, they have code pipeline, which you can leverage their CI/CD system that they have. Otherwise, you can go in for other systems like Circle CI or Jenkins to build your pipeline and deploy it to AWS. Um, Using CloudFormation, also you can do this. So yeah, there are options to integrate this with CI/CD systems.
All right. Thank you, Santosh. So we have a next question. Let's say if Elastic Beanstalk gives us so much flexibility to change configuration, when are we supposed to set up EC2 and other services, and when should we just use Elastic Beanstalk?
Yeah, I think that's a good question. So there are pros and cons of Elastic Beanstalk. So let's say your company is a startup and you do not have an DevOps expertise or cloud computing architects and if it is not a very complex and mission critical application, I would encourage in those times, or if you're doing a POC and you have like quick time to market, you want to go, I would suggest during those times to use Elastic Beanstalk or to leverage that so that you can quickly understand the components that are created. And you can, at any time of point later in time, come back and revisit your architecture. So, so to answer that question, if there is not enough expertise in using cloud technologies and you don't know where to get started, I think Elastic Beanstalk is the best option.
All right. And there is one question related to the same, like how is it similar or different from AWS Amplify?
Um, Actually, I have not heard about AWS Amplify, so not the right person to answer. I will try to see what it is, and if I get the answer, I'll get back to you.
No problem, Santosh. Thank
Yeah.
you. Okay, guys. So moving to an end of the meetup, I would like to request once again to provide us your valuable feedback. Feedback form link is already shared in the chat. I would like to thank the audience for attending this event, our speakers for sharing the knowledge effectively, and of course our volunteers who are at the backstage and yeah, helping us continuously to make this event successful. We wish to see you all back in our next edition of our Tech Meetup soon. Thank you very much.
Thank you.